Hello there, folks. This is Joe Ozu here. Hey, this quick video is going to talk about a way to take two 16-bit integers and put them together as a 32-bit word as long. Um, in this case, the customer actually has an old Allen Bradley PLC5 that he's got a couple of registers mapped to the N7 registers, and he needs to somehow combine those together into a 32-bit word that he can send off to an OmniFlow computer. So I'm kind of showing this example here where these two N7 registers are coming from the PLC5, and we want to put that into an OmniFlow computer as a word as long or 32-bit word here. So the reason that this came up as a problem is if I look at the DF1 driver, this is what he has for this application, and I want to show you something. If I pick the PLC5, and if I go down here and add a gateway block real quick, I just want to show you something. No, I don't want to click that button, not import. I want to add a gateway block here, right here. If I click on the gateway block, I want you to see, here are the N7 integers, and here they are. But the problem is, typically on other drivers, we have a red line. Down here, you'd see word is long, or word is real, which would allow you to combine two 16-bit integers, particularly if you did word is long, and put together as a 32-bit. But that is not an option with the Allen Bradley PLC5 DF1 driver here. So here's what I did for a workaround in this case. I actually have, in this case, a couple of registers, tags that are mapped to an upper word and a lower word. In this case, I'm using Modbus, but the same exact thing. And then on the display page, I've got the tags here we can show off. I got two ways that I can combine this into a word as long. One way is I could write a program. So over here in programs, I've got a program written. I have an internal tag declared here called internal tag. And then I basically take internal tag equals the upper word. And then you see these two less than symbols here. That's going to do a bit shift and move that over 16 bits to the left. So that'll make that the upper 16 bits, that value, and the lowers are all going to be zeros. And then the next line takes that plus this, which this lower word is all just 16 bits of the other half, and that'll put it together as a 32-bit word as long. That's one way. And of course, you could execute this program on tick or some other way. That's one method. The other thing I want to show you here about this, before I go too far on the other idea, is if I go back to data tags, notice both of this lower and upper, if I click on them, I'm not doing any formatting on these at all, on the upper and lower word. By default, Redline will declare up to 5 digits for this, or 16-bit. Believe it or not, they are 32-bit values, but they are 16-bit here by default. I have this other one here called word is long. And I want you to notice something, word is long. On the format tab, I have hit the pick button here, and I declared that as a numeric type. And the reason I did that is because that gives me access to change the digits before from 5 default to 10. So that'll make that a 10-digit or 32-bit number in this case. So that's what it's going to, 32-bit integer. That's that particular tag. That word is long is right here in the program. That's where it's going to be executed. Or I want you to see something here. I have another tag here called formula tag, particularly if you're using a DA10 or DSPLE, where you don't have access to programs and other things. You just basically have communication and data tags. If you want to do this with a DSPLE or a DA10 product, this is what you would do. You create a formula tag here, just a new tag. I happen to name it formula tag. And you see out here where it says complex? What I did there is hit the pull down, and normally it'd say internal. I chose complex, and then if I hit the edit button, you're going to see here the exact same code that I'm running at the program, except for this is at the tag base. So I don't have to execute this at all. It just happens all the time whenever one of these values change. Exact same code that I'm running in the program. Here I have an internal tag I declared as int, internal tag, semicolon. The next statement is internal tag equals upper word, bit shift, the two greater than or less than symbols, moves over 16. The next one takes word is long, equals that, or this return takes internal tag, does the same math, but that's what this returns as this value. So let's test this out, team. I think I've got this running locally. Let's go ahead and download it to my thing here. Let's see what happens here. All right, so this here is the database on this side I was just showing you. This is the PLC5. So let's try a few things. So if I put in the N7 word, lower word here, go ahead and hit a 1 there. You can see that's the one, word as long as 1. That's perfect. Looks good to me. If I change this to, say, 32,767, what do I get there? Looks like it matches. Sounds good to me. What if I go 65,535? Looks all good. What's interesting about the number 65,535? Well, that's 2 to the power of 16 all ones. So if you had 16 ones, that is the decimal equivalent of 2 to the 16th. Now, what if I roll over one more? So I can't go any further in this one here. That's the maximum because that is 16 bits. If I go ahead and make this guy 0, let's make this 0. Let's click on the next one here. Let's put this guy at 1. Let's see what happens this time. Okay, see how that rolled over there? That's exactly right. Correct. Perfect. Now, let me back up here. I just missed something I just saw. Okay, so let me put this back at 65,535. Okay, so these numbers all look good here. This looks great. But I'm also taking those numbers and trying to send them over to the OmniFlow. And if you look here, this is the same register shows up in OmniFlow. And look at how weird, how big it is. Why is it so different? Well, let me go ahead and put this back to 1. Let's see what happens if I... So look there. If I put it at 1, you can see that's 65,536. That's interesting. Let's put this guy at 0. Okay, that's 0. How about if I put this at 1? Let's see if something jumps out at you. So when I make the upperward 1, this shows 1, but this is backwards. Here's the problem. These two really values are kind of reversed in the order that I want to do here. So if I go back to Crimson, particularly the word as long tag here, let's go to the word as long. You see right here where it says manipulation? I'm going to do reverse words on this guy. And I don't think you can do it on this one. Can I do it here? Oh, you know what? Let's do this. Let's leave this as normal, none. And let's go to formula tag. Let's make that reverse words. All right, that should invert the words. Let's save that. Let's download team. Let's see what happens here. Remember, this was a 1. I got these set to retentative, so let's see what happens here. Should reset. Hey, look at there. Okay, I should change the other one. See how that guy's off now? Yeah, let me put this back to 0. And if I put a 1 here, let's make sure our math is working. Nope. Well, hold on. Let me look at my math here. Hold on. Let me go over here. Sorry. Let's see. What am I doing there? That's good. Yes. That's the one. Let me change this one here to reverse words. Okay, now let's try it. Now we should be looking good. I should have did both of them, but this now I got both of them as reverse words. Let's see what happens here. All right, so there's the 1. Oops. This one doesn't need to be. Okay. Sorry, team. This is probably with my flying by the seat of my pants here sometimes. This should fix it. Did I download that? Oh, yeah, there it goes. Okay. Good coffee today. Good coffee. All right. We should see a 1 and 1 here. There we go. Perfect. So again, if I put this to 0, enter, put this to 1, we should see 65,536. That's perfect. That is awesome. If I put another 1 here, that should go to number 7. That's beautiful. Worst case scenario, the biggest number you could have here is both the lower and upper be 65,535, which is all 1. So let's try that. 65,535. There you go. And let's put this guy at 65,535. There you go. That's the biggest number, 16-bit, 32-bit word. That's the number it could be. So that's all there is to do with this. Like I said, you could do this in a DSPLE using the formula tag, DA10, or if you have a DA30 or something greater that has programs, you can also write a program that does the same thing. I'm doing the program here, or you can do the logic, add a tag, and do it right here as complex. Anyway, that's an easy way to take two 16-bit words and combine it together as a 32-bit word as long type of tag. Hey, team, if you got any questions or you want to copy the database or something, please don't be afraid. Send me an email. I'll send you the database. Hey, thanks a lot. Have a great day. We'll see you later.